Hello, everyone, and welcome to our presentation. We're Push Forward Security, and our project is the Gibson. Our team consists of Patrick Patterson, Hunter Kish, and myself, Stephen Reynolds. Our project background. What we offer is a red team exercise. We simulated a hacker incident where we tested the security of a simulated small business. This includes network attacks, domain attacks, hardware attacks, software attacks, and physical attacks. We kept a record of exploits used on the user. Security should be a company's main focus. You don't leave your doors unlocked. Why would you leave your company's information and infrastructure open? For hackers and other malicious entities getting in, a breach can damage your company's reputation, incur fines from regulatory bodies, from leaked customer information, cost to repair damage, loss of data, revenue loss while services are down. No one wants to deal with any of that. Solution, our solution to the approach. A solution to a problem. Simulating an attack on your company's infrastructure will expose weaknesses. This is critical because security seems secure until you have a third party test it. With our help, small businesses will have a comprehensive list of problems with their current security setup, and they will be able to adjust and improve. The value of the solution. Ensuring your company is secure. There is a must preventing attacks on your network, and protecting your infrastructure and important data is critical. One breach can ruin a company. Our value comes from expertise and real-world examples of an attack. On your company knowing your vulnerabilities are being prepared, an attack isn't possible, it's inevitable. A review of our system. Our components include security, networking, hardware, software, and server services. Security. The security aspect of our project. We created a secure environment to test on. This includes having a firewall on our clients and server host, having a fleshed out Active Directory, AD for short, that will have a built-in hierarchy, which will be a few employees, one system admin, and a few department managers. With the hierarchy we have made, it is as close to a small business setup as possible. So we will have different levels of user security. We focused a huge part on security to make it as realistic as possible. This gave us the best starting point to work around and see how much breaking of the system we can do. With the information that we gained from these tests, to keep them secure, because we are not going to hand these tests to a real company, we're going to store all information locally on an external hard drive. Networking. For our network, we built a private network, so we can do attacks on a secure network. Our network consists of most common elements in a small business. We used a single router to build a network. We created a domain network to simulate regular domain infrastructure, including a domain name service, DNS, and a dynamic host configuration protocol, also known as DHCP, which are commonly found in most small businesses. Our network consists of our server hosting, our Active Directory, our DHCP, and DNS, along with a host computer. Hardware. We have two computers running VMs, one running a server environment and the other running as a client. We will be building a couple penetration testing tools out of Raspberry Pi 3 and an Arduino board. These tools will emulate common pen testing tools, like a rubber ducky and a Dropbox. A Dropbox is a small single board computer, used to give you a physical connection to the client's network, while being as inconspicuous as possible. The Dropbox will be used for reverse SSH tunnels, OpenVPN, network monitoring, and wireless attacks. Rubber duckies. When a rubber ducky is plugged into a computer, instead of registering as a USB device, it registers itself as a USB keyboard on the system and fires off keystroke payload at lightning fast speeds. We will be using these tools as an example of a physical attack on a network. In order to build the rubber ducky, we used an Arduino DigiSpark board. Software. So the software portion of this project is a huge chunk of it, and will be the main way that we test our environment for this project. we ran into two types of we used two types of penetration tests, one internal and one external. The reason that we chose to run both types is because it will show us the most realistic results as companies in the industry will choose which kind of tests they want to have run. Internal will be a computer with a network that is hosting the penetration test, while external will be a penetration test from outside of the network. When we are testing the firewall, that is considered an external test. This kind of test can lead to an internal penetration test, but to keep the results precise, we're going to run one externally and one internally. A well-done penetration test can show a company exactly where their strengths and weaknesses are in their infrastructure. Our penetration test will be considered white box. Because we are creating the environment, we will know everything that is in the environment, and that's what a white box is. An example of a black box test would be we would need one team member to open vulnerabilities, and the other two team members will run the tests. This ensures that the attackers do not know what the environment looks like. This kind of test is used mainly to see what the response team does and how fast they can realize an attack is happening. And our server services. We will be building a domain to emulate a small business. This includes usual services, such as an Active Directory used to delegate roles and responsibilities to admins and users. So we can simulate having active users in an environment with different roles and different permissions and access rights. A DNS will be required so we can add client machines to the server, a DHCP to delegate IP addresses to our clients, as both would be found in a common small business environment. And I'll be passing it over to Patrick here to go over our budget. Thank you very much.
Awesome. Thank you, Stephen. So I will be talking about our budget. So our budget can be broken down into several different categories. So firstly, we have our material cost, which can be broken down into all of our physical hardware. Everything in green, we actually were able to supply through either SATE's resources or our own personal resources. The one thing in red, the rubber ducky, was something we did have to purchase on our own. As well, over in the software column, we also have all the softwares we would have had to purchase, but thankfully we don't have to purchase any software being in this program. As you can also see, we broke down how our total labor cost would work. Total labor cost per day to pay per person, the total project time, and then the total labor cost per person. Did some math to figure out the total cost of it. So our total labor cost came out to $112,896 to pay the three of us, while our total cost with SATE stock was $112,899 because our material cost was only $3 due to the fact that everything was actually supplied for us. So that was actually very useful. Now, moving on to our list of features and functions we had hoped to deliver. So first, our infrastructure. We wanted to build an environment with proper VLANing for each department, as well as an Exchange server, a full-fledged Active Directory, as well as a safe environment for testing. To get into more of the tools we wanted to use for our pen testing, Stephen mentioned earlier the Dropbox, Rubber Ducky, Mousejack, and then some more software-based things like Nmap, Legion, /Brute, Rainbow Crack, and HPing, as well as our documentations for the full penetration tests, our tabletop documentation, our playbook, as well as our pen testing analysts. And then moving on to what we were actually able to deliver. So we were able to deliver our playbook, which is used for guiding users in using the tools we provided, as well as software detail on each program, as well as a glossary for each program to give a little bit more background and understanding into what they are used for and how to use them. As well, for our server services, we were able to build our full environment, including a DHCP, a DNS, wireless access point, Active Directory, and a file share. Our client machine and our domain access points, we had 2 root of access into our environment, our domain computer, which ran all the server services, as well as the Active Directory, and then just a regular client machine to use as an access point. And then our Kali machine penetration testing software, which we ran a lot of our software through because it's readily available through it. So Nmap, Legion, Brute, Rainbow Crack, HPing, and Rubber Ducky. And then what we weren't actually able to deliver, unfortunately, would have been our Dropbox, Rubber Ducky, Mousejack. Those 3 kind of run into the same problem to where we no longer had access to our hardware, so we weren't actually able to develop these utilities to use in our testing. What we also weren't able to deliver on was an Exchange server we would have liked to set up. Just the material wasn't quite readily available for us. We would have needed another entire computer or server by itself. So we decided not to go through with that, as well as our tabletop simulation, as again, no access to the environment, unfortunately. Now, what we could have done differently? Well, first, start research for the playbook early on, as well as any other research we needed. I personally didn't think I didn't think about how long it would actually take to do this research, and should have started it a lot longer ago, honestly. Moving on to our second point, starting out with a template for the website and changing it back instead, changing it then instead of making a website from scratch. Hunter had a lot of issues making the web page, but because he was building it from scratch, which was actually very difficult and hard to do as someone who's only taken 1 class on it, as well as holding ourselves to deadlines. All of us are not very great when it comes to deadlines. We try to create our own deadlines for ourselves, but without like really anyone pushing it or anyone holding us to it, our deadlines kind of got moved all over the place, as well as not letting the current situation affect our work, with the effect of COVID-19 on our schooling and the environment of how we were working with everything. I think we let it kind of get to us a little bit, and it really did kind of slow down our work when it came to especially that last 10% of the work where most of the critical work comes into. And then I'm going to actually pass it to Hunter to talk about our greatest challenges we had to overcome.
All right, thanks, Patrick. So our greatest challenge to overcome of this project would be the fact that in our 3rd semester, we had our project pulled at the very end of it. This required us to create an entire new project from scratch, including all the documentation that we had done 3rd semester. This only allowed us to have 4 months to complete the project instead of the standard 8 months. The greatest lesson that we learned from this is, due to this restart, we were forced upon, at the start of the 4th semester, we learned how important time management is when it comes to a project like this, as shown in our journals. I know for Patrick and I, our journals for the first month or 3 weeks is a lot of working on documentation such as business case and functional spec. The conclusions, so the budget, schedule, and scope and functionality. So in conclusion, our final budget cost comes to $113,779.78. This amount includes the total labor costs and total hardware costs while using state and personal equipment. We did decide to keep this final budget cost as our cost because before this COVID-19 happened, this would be what our final cost is, and we didn't think that it was fair to knock off the hardware aspect of our budget as we had it on there all year long. The timeline of our project was appropriate. When it came to certain things such as the playbook, as Patrick had talked about earlier, and other research, we did underestimate the amount of time that those tasks would take. Our scope was followed throughout the project. We were unable to deliver certain features of our scope due to the loss of our physical environment. And functionality-wise, our project reaches the key targets of what we wanted to accomplish, in that we could help provide a security audit for a small business while only missing some qualities of life features. So recommendations for further research, upgrades, and improvements. Probably the best thing about security is that it never stops. You never hit a flat point when it comes to the learning curve of security, just because daily there's new exploits, there's new hackers, there's new malicious code that pops out, and people have to find a way to stop that. A great way to stay on top of all this is to get your OSCP certification, which is just a pen testing certification. Upgrades that we would like to recommend is a Kali machine with a graphics card to improve calculation heavy programs like Rainbow Crack. And improvements would be a more secure simulated business, making a harder challenge. So creating as close to real small business infrastructure that we could make, just to make sure that our tests were 100% accurate with real infrastructures. And that's it for our project.